minus. Thank you, Naman, for the cheer of 300 bits. Thank you, Justin, for the follow. Okay, so what's up with this? It's so you want to find all positive integers b such that every number of the form b to the power minus 1 over b minus 1 is a triangular number. Is that right? This feels... So, first of all, I want to say... Really? Like... Is there any b for which this is true? I have a really hard time believing that. Like, you can always get a triangular number. Okay, well, the problem is positive, right? I'm just trying to think, is there any b for which this is, like, even remotely possibly true? Like, I want to say, like, no way in heck. Like, no way, right? Like, I honestly don't even... I'm not even sure I can get it to be true for c equals 1 and c equals 2. B equals 9. 91 is not a triangular number, right? Try the things. Okay. Okay, so we're going to get rid of the triangular number bait, first of all. And we're going to get rid of the geometric series bait. Like, there's... Triangular numbers aren't that special. So we're going to write 8 times 1 plus b plus plus b to the c is equal, apparently, to 4n squared minus 4n. So we want this number to be a perfect... Okay, so the point is I want 8 times... So in other words, this guy is always a square. Wait, 9 to the c plus 1. Wait, 9 works? No, wait, like, is 91 a... It is a triangular number. Okay. Wow, now I feel stupid. 91 is a triangular number. Yeah, that is correct. Okay. Well, if there's one, there might be more. So let's keep pushing. So we'll write it, you know, everyone wants to write the geometric series in, so let's just do it. Plus 8b. The reason I'm astonished is because I can't tell, like, b equals 9. Yeah, this formula is actually pretty bad. It might not have been correct to do it. It's just, 9 doesn't look like it should always. Okay, when b equals 9, what is going on? When b equals 9, the assertion is that 9 to the... Why did they use c? Can I just use... Okay, 9 to the e minus 1 plus... Like, I'm just, like, shocked this statement is true. 9 to the e plus 63 over 8 is always a square. And if that's true... What is the... It should be, like, an expression, right? So, it should grow, like... Oh, shoot. Sorry, I put the 8 in the wrong place. You know what? Let me not. Yeah, I'll just leave it as. So we're going to write b to the e minus 1 over b minus 1 plus 1. So the assertion is that... oh, okay. Well, is that 9 to the e is a square, which is true. That seems pretty fun. Okay, fine. I agree that it's always a square. What about everything else? Okay. More now. Suppose. Let's go the other way. I believe b equals 9 should be it. So for e equals 1 or equals 2, we find 8 times b squared minus 1, so b plus 1 is a square. Where's this gonna go? Think a few steps ahead. Yeah, 9 is special because it is 1 more than 8 and is a perfect square. Like, cause here's the intuition. Like, if I told you something an expression that looked like this was a square for every integer e, then you would imagine it must be a square for trivial reasons, like that you can actually write it as a square of the thing. And there's no way that it's gonna, yeah. Do you want me to just consider the square of adjacent terms? Wow, I got an email. Thank you. Like I even wonder, like, what if can I just like take some finite number of values of e? Okay, here, I'm gonna, this is very rude, but I'm gonna do the... Geico Lizard, you say that as a joke. I've actually gotten messages that are like, I think, of that shape. Okay, I'm gonna do what's called, here. Once upon a time, there was a contest called EGMO, not to be confused with a book. And there was a problem that looked like this. And I got baited by it. Or I kept trying to do a Pell equation thing, which is the same instinct I'm having now, but I have learned my lesson, and we are not making that mistake again. And let's just hit it with a big hammer. So, accordingly, 8b plus 1 times 8b cubed plus b squared plus b plus 1 is a square. Oh, Jesus. This might be kind of... But I know it's gonna work. I am not making the mistake again, you know? Just... Full steam ahead. Okay, so, product of e equals 2 and e equals 4 case. Similar to 2003 and 4. Okay, so this is 8b plus 9 times 8b cubed plus 8b squared plus 8b plus 8 plus 9 equals 2 and e equals 3 cases. See, the problem is if you try to combine e equals 2 and e equals 3, you get Pell stuff, right? Like, the reason I picked e equals 2 and e equals 4 is the product is a polynomial of even degree with leading coefficient equal to a perfect square. And when that happens, you can bound it between two polynomials. Did I miss a mute me request? I'm sorry, Justin. I'll do that now. There you go. Don't expand. Keck. Why would you want to be muted? I don't know. Okay, 64 b to the 4 plus 136 b cubed plus 72, 136 b squared plus 144 b plus 81. Oh wow, some beat me to it. And this is equal to like 8b squared plus, oh jeez. Okay, I want the b cubed coefficient to match. The b cubed coefficient is 17 over 2. And then I want the b squared coefficient to match. The b squared coefficient is 289 quarters plus 16 times something. 289. Is this right? Wait, I think I messed up. No. I want the denominator of... Okay, so... Breathe in. Breathe out. Okay, so... b squared is... So I need... What's 136 minus 289 over 4? Is 315 over 4 and then divided by 16. So 315 over 64, I think is the correct. No. Yeah. I believe so. Okay, and then what's left over for the b? Oh my god. Wait, why is this coefficient so bad? Okay, so 315 times 17 is equal to 5,355 over 128. 255, yeah, so 144 times 64 is 2,304. So 3,051 over 64 times b. That's the leftover b coefficient. And then the... What is 81 minus... that's actually larger than I can do by hand. Oh, did I mess up? Yeah, I was like, the denominator shouldn't be this large. Did I screw up? Okay, okay. 17 halves, you claim is correct. The problem is the b squared... Nah. I'm just gonna write 81 minus 315 over 64 squared. Is it 255? Oh no. Oh no. I'm getting old. Okay, if it's 255 over 64, then if I want the b to match up... Okay, thanks. 481b64 plus 266,751 over 4,096. Okay, amazing. See, the problem is b equals 9 is a solution, and it's pretty big, so we sort of like have to reach there. This is really rough. Okay, so if b is larger... Right, so let's multiply the whole thing by 4096 to clear all the denominators. And so this is equal to like... So 4096 is 64, so there's 512b squared plus 544b plus 255 all squared. And then plus the error, so 64 times 4881 is 312,384, I hope. Someone check my arithmetic on that. 66571. Okay, so we're okay once so this is trapped between that giant quantity squared and what do I know? This should be a perfect square that's divisible by some pretty... Because I multiplied by 4096, my square must be divisible by... The thing inside the square should be divisible by 64. So, if b is large... Oh, but 256 is... Okay. Freak. If 3123884b plus 266571... Oh, I'll just do the dumb bound. So this is true for all b, which is if b is greater than 700, then this inequality will be true. Did I swap 7 and 5? I'm gonna just say that's a typo. Yeah, so it's supposed to check b, all b at most 700. However, we also know 8 times b plus 1, all plus 1 is a square, and also like 8b squared plus b plus 1 is a square. So this will not take too long to check, I hope. But this is really not efficient, actually. I want a bigger coefficient. Less than or equal to... Well, yeah, I mean, I wrote strict, but, we can take mods now. Just like all NT. So, we know that... Okay, so I'll go back to the left. So we know that b is like... From e equals 2, candidates are b equals... Oh yeah, b should be 1 less than a triangular number. That's... Oh shit, there's a lot of those. There's a lot of those. Okay, do I want to do something with 8b squared plus b plus 1? Well, we'll force it with the Pell equation. How about that? From 8b squared plus 8b plus 9 equals... x squared, we get... So first I want to complete the square. So 4 squared plus... Well, we'll let this be 2x plus 1 actually. We have 4b squared plus 4b plus 4 is equal to 2x squared plus 2x. So we get the Pell equation. See, this is the thing I was trying to do on the EGM over. When I saw the Pell equation, it's like, this should tell us a lot, but it's just not enough. 2x squared plus 2x. Wait, hang on. Why didn't that work? Yeah. See, the problem is triangular numbers grow quadratically, but Pell equation solutions will go exponentially fast. Okay. Sorry. Let me try this again. From 8b squared plus 8b plus equals x squared. If I divide both sides by 2, I get 2b plus 1 all squared, 4, 4, 1, 8, 8, 2, minus x squared equals 7. Actually, I'll write this as x squared minus was negative 7. So, oh shoot, but because it's negative 7, I don't have enough Pell theory to do it, right? I thought it would be plus minus 1, in which case you're fine. 7 is fine. You can find solution. Okay. All right. You know what? I'm gonna. I was hoping I wouldn't have to do this, but I will try to optimize this a little. So the next squares which have enough factors of 2. So again, the thing inside has to be divisible by 64. So the next ones are 512b squared plus 544b plus 256. All squared, and the next one after that is 512 plus 544. 544 has a lot of factors of 2 in it. Like, it's because it's 17 times 32. The next one will be 288. So check the first one. So we'll solve the polynomial equation on the left. The first polynomial equation we should solve is 512b squared plus 544b plus 256 squared is equal to 512b squared plus 544b plus 255 all squared plus the this thing. And then for the other one, we can use size arguments. Because when I'm up to 288, you get a factor of 32. And so, however, it being less than 32384b plus 266751 is less than 32 times, sorry, 33 times the sum. Like, this is how difference of squares works, right? 33 times 1024b squared plus 1088b plus 533 holds for all b quite... Yeah, you don't need b very large for this to be true. You just need b... 30,000. So holds for all b greater than like 30 or so. You don't even need 30, right? You need like b to be greater than 10. I think b greater than like 10 is enough. B at least 10. Is that right? Like this guy is like 33,000. This is 312,000. So if b is at least 10, this inequality is true, and we don't have to. So you can't get all the way up to here. So then I just have to solve this guy, and this is a linear equation. It has at most one solution. No, it's not a linear equation. Sorry, it's not linear. However, we'll rewrite it as 312,384b plus 266,751 is equal to twice 512b squared plus 1024b squared plus 1088b plus 511. I have a really long backlog of things to type up. So, does b equals 9 work? So b equals 9 works, but it's a quadratic, right? So there should be another solution. What's the other solution? By Vieta. Okay, so 266,751 minus 511 is 266,240 divided by 1024. Oh, the other solution is negative, so it doesn't matter. No, so we'll say no b equals 9 works, which I think it does because both sides will be equal to... Are you sure b equals 9? Oh, it doesn't work. Okay. Alright, never mind. So we have to manually... 266... 240. Okay, this number should factor, right? 3, 3, 2... So let's take out the 266, 240. So let me divide out by 40. 6, 6, 5, 6. And that looks like it still factors of 4 in it. So 1, 6, 6, 4. That still has factors of 2 in it. So let's extract those. That is a lot of factors of 2. What am I doing? Let's take out 16, right? And it's 104. And that is factors. Yeah, wait, I'm confused now. Did we make a mistake? Like, b equals 9 must be a solution because it has to show up. So I hope I didn't miscalculate. I'm confused. Like, we know b equals 9 is a solution. So is the plus 288 case? Oh, I see. Okay, no, we're fine. So I just need to kill off this case. What I'm really hoping is like there's a random mod I can take to show this particular equation just doesn't have integer solutions. But I don't think I'm that lucky. Sorry, 2 to the 19 is wrong. I meant 2 to the 12. Okay, so we have to check... we can check b less than 20 doesn't work. I also need to check this giant quadratic has no integer solutions. So... Or at least I need to check all the factors of this guy do not satisfy the problem condition. Oh, wait, can I just divide 1000? Oh, hahaha. 7, 5, 2, 4, 0. Okay, so 1024b squared minus 311,296. Okay, and then Okay, so it's just a multiple of 1024. That makes life a lot easier. B squared minus 304b plus 260. Okay, does this have an integer solution? Okay, its discriminant is 304 squared minus 4 times 260, which isn't a square. The reason it's not a square is because it's too close to 304 squared. Yeah. All right. I don't. Wow. Hey, I don't see equals to b equals 1 minus 8 check. Oh, 1 through 8. Yeah, okay. So you plug it into here. You get b equals 1 doesn't work just in general because here. But actually, b equals 1 works up to like b equals 33. B equals 2 gives you 57 here. B equals 3 gives you 33 here. B equals 4 gives you 41. B equals 5 gives you 249 here. B equals 6 gives you 57. B equals 7 gives you 65. B equals 8 gives you 65. Okay, so we're fine. No, sorry. B equals 8 gives you 73. Yeah. Yeah. I'm... Alright. Who suggested this? I mean, I'm sure there's like a reasonable solution that isn't this. It's just like, it's... I didn't optimize at all, which was probably a mistake, honestly. Like, in the EGMO problem, for example, you could optimize it as well if you just didn't hit the square so carefully. Like... check the Google Drive for a better solution. What am I looking at? So I look at the squares. Fine. Yeah, I don't know. Like, I think this the reason that this solution I think is nice is it shows you that you only need like e equals 2 and e equals 4. Like, you should only need 2 well chosen. If you choose if you choose 2 consecutive well sorted ones, yeah, you don't need every C. I really... Oh, I think this one's easier to think of because I got burned by this in April. Like, I kept trying to chase the Pell thing. But you don't need to.